Okay, so we've learnt about pressure in gases and we've learnt about pressure in liquids, and now we're going to learn about pressure not in a solid but between two different solid objects. So you'll remember that I said that pressure was the force in a certain area. Okay, so let's think about a situation that will make this understandable to us. So when it snows, if you go outside in the snow, okay, so this is my picture of, this is the surface of the snow here, and then this is the ground. Okay, so there's quite a lot of snow here. Let's say there's maybe, let's be generous, let's say there's 20 centimeters of snow. Okay, if you go out with and this is your foot here, your normal foot, and you step on the surface of the snow, then you are going to go through the snow to the ground. Okay, and that's because the force of your weight pushes through the snow. Now, in some countries where they have a lot of snow and they don't want to always be falling down through the snow, they wear something called a snowshoe. Okay, and that looks like this. So this is their foot, and then this snowshoe. Okay, you might even see some people with, tennis rackets maybe on their feet. Okay, so it's sort of like that. It's this big thing that they can put on the bottom of their foot, and what that does is it spreads out the force from their weight over a larger area. Okay, so it's really important that you can see that in these two different situations, we have same force, because it's you in both cases, so your weight hasn't changed. So it's the same force, but we've got different areas. Okay, and here, because it's a smaller area, this is high pressure. And here, because this is a large surface area, this is low pressure. And that's why if you wear snowshoes, you don't fall through the snow. Okay, and we can quantify this by putting it into an equation. So we can say that pressure equals force divided by area. Okay, and the force will be measured in newtons. The area we can measure in centimeters squared for now, and the pressure would therefore be in newtons per centimeter squared. Okay, so let's do an example. All right, let's say that you have a force of 600 newtons. Okay, that might be a little bit generous, but it's fine. Force of 600 newtons. All right, now here we can say that the area of your foot is 100 centimeters squared. Okay, which roughly is 10 centimeters by 10 centimeters. It's an approximation, but it's 100 centimeters squared. Now, let's say you put on your snowshoe, and when you put on your snowshoe, this is going to make the area that you step on really big. Okay, so let's say it now becomes, let's say 600 centimeters squared. All right. So it's made the area of your foot much, much bigger, but the force is still the same. Okay, so now we can work out the pressure in both cases. So the pressure over here would be the force, 600, divided by the area, 100, which would give us 6 newtons per centimetre squared. And what that means is every square centimetre gets a force of 6 newtons. And because there's 100 square centimetres, you get a total force of 600. All right, now, over here, what do we get? Well, the pressure is going to be the force, which is still 600, divided by area, 600, which is 1 Newton per centimetre squared. So you can see that by increasing the area, I've decreased the pressure for the same force. Okay? So we can now look at a really interesting example of where this becomes important. There's a question in the Caboodle textbook, which is, the point of a nail has an area of 0.25 centimeters squared, and an average person has a weight of 700 newtons. Explain in detail why it is possible to lie on a bed of 4,000 nails, but not on a single nail. Now, if you want to have a think about that yourself, you can pause the video. Otherwise, I'm now going to go through why it's possible to lie on a bed of nails. Now, you might have seen people do this, or you might have seen videos of it. Okay, and it looks painful, but really it's not. Okay, so let's imagine you have situation A, which is one nail. Okay, so we can now work out the pressure is going to be our force, and we said that the average person was 700 newtons, divided by, all right, well, the surface area of the nail is 0.25 centimeters squared. Okay, so if I do that, I will get 2,800 newtons per centimeter squared. All right, which is huge. Okay, up here with the snowshoes, we were thinking about 1 Newton per centimeter squared. Now I've got 2,800 newtons per centimeter squared. This is a huge amount of pressure. All right, so if you were to stand on one nail, then yes, this pressure is very, very large, and you would probably hurt yourself because that's quite a dangerous amount of pressure. However, in situation B, we had 4,000 nails. Okay, so what's the pressure going to be now? Well, first we need to work out the area of 4,000 nails, okay, which is going to be 4,000 multiplied by the area of one nail, 0.25, which equals 1,000 centimeters squared. So the pressure now is still 700, but it's divided by 1,000 centimeters squared, which is going to give us 0.7 newtons per centimeter squared, which is tiny. Okay, it's even less than we have with our snowshoe up here. So you can see that by increasing the number of nails, we've increased the area that the force acts over. And because we've increased the area, the pressure has decreased. Okay, and you need to be able to use this equation here, to work out pressure. All right? Excellent. Very good work today. Well done.